This is day 25 of Advent of Code 2023, and this challenge is called Snowverload. Still, somehow without snow, you go to the last place you haven't checked, the center of Snow Island, directly below the waterfall. Here, someone has clearly been trying to fix the problem. Scattered everywhere are hundreds of weather machines, almanacs, communication modules, hoof prints, machine parts, mirrors, lenses, and so on. Somehow, everything has been wired together into a massive snow-producing apparatus, but nothing seems to be running. You check a tiny screen on one of the communication modules, error 2023. It doesn't say what error 2023 means, but it does have the phone number for a support line printed on it. Hi, you have reached Weather Machines and so on Inc. How can I help you? You explain the situation. Error 2023, you say. Why, that's a power overload error, of course. It means you have too many components plugged in. Try unplugging some components and you explain that there are hundreds of components here and you're in a bit of a hurry. Well, let's see how bad it is. Do you see a big red reset button somewhere? It should be on its own module. If you push it, it probably won't fix anything, but it'll report how overloaded things are. After a minute or two, you find the reset button. It's so big that it takes two hands just to get enough leverage to push it. A screen then displays System Overload. Connected components would require power equal to at least 100 stars. Wait, how many components did you say are plugged in? With that much equipment, you could produce snow for an entire... You disconnect the call. You have nowhere near that many stars. You need to find a way to disconnect at least half of the equipment here. But it's already Christmas, you only have time to disconnect 3 wires. Fortunately, someone left a wiring diagram, the puzzle input, that shows how the components are connected. For example, JQT goes to these go to these, and so on. Each line shows the name of a component, a colon, and then a list of other components to which that component is connected to. Connections aren't directional. AB to XYZ and XYZ to ABC both represent the same configuration. Each connection between two components is represented only once, so some components might only ever appear on the left or right side of a colon. In this example, if you disconnect the wire between HFX and PCL, the wire between BVB CMG, and the wire between NVD and JQT, you will divide the components into 2 separate disconnected groups, one with 9 components and then one with 6 components. Multiplying the sizes of these groups together produce 54. Find the 3 wires you need to disconnect in order to divide the components into 2 separate groups. What do you get if you multiply the sizes of these 2 groups together? Okay, interesting. So start off, of course, grabbing input and putting that into here. So we will do wires as a dictionary, then for line in F, we will do line equals line.replace colon with nothing. Then let's print line.split. Let's see if that gives us the output we are hoping. Oops, wrong day's input. That seems to work, although I probably should actually not replace it. We will do initial and others equals line.split colon, actually colon space, we will do that, and then others equals others.split. So let's do this, see if that gives us output we want. Yes, it does. Yep. So would this be... Okay, so JQT would connect to RHN, this one and this one. So all 3 of these connect to this, and it would go through the list like that. So for line, we will do for... Actually, we need to do others equals others.split for wire. Actually, we can just do that for wire in others split. Wires initial equals wires.get initial or new list plus wire. What's going on here? Okay, well, that was weird. Having issues with the indentation, but anyway, we've got this now. So adding wire to that. Then we do the inverse. So wire initial. So we do that. Then we can print wires, and that should be all good. So JQT. Yep, so that's working. Actually, I'm going to change this so it's a set, just so we can make sure nothing happens while working with this. So we accidentally, while working on these lists, I don't want to accidentally add values into it, just in case. So, you know, change it to a set. Change it so it's a set with the wire in it. All these values. Nope, that's not working. So let's do this instead. Okay, we're going to change it. Let's just initialize a set, and then we're going to add to it. I think that would work. There we go. So now we've got the sets in there. Okay, so what do we need to do? So we're going to need two groups of the wires initially. So in this dictionary we've got all the, basically every single key in that dictionary is an individual wire. So we're going to do, what should we call it? We'll do wire group, and we're going to do set on wires dot keys. See if that works. Print wire group. Okay, we've got that now. Let's remove this dictionary. Okay, I've now got every single key in this set. And I think maybe we just need to go through and remove the dictionaries with the highest amount of keys, like this, maybe? Maybe for I in range 3. Then we do, what do we do? So we've got to remove from the set. We've got to find the wire which has the greatest number. So would that be, so wire group dot remove. Then we could do max wires in wire group, but then we change the key, and this can be a lambda wire, and this will be based on the length of wires W. Change that to an underscore. So let's take a look at print wire group. What does this look like? So removed to, okay, I don't think that is correct. Yep, so that's definitely not correct. Let's then also print set wire, set wires dot keys minus wire group. So what is, which ones did we get rid of? We got rid of NVD, so NVD, LSR, CMG. Okay, so why did LSR get removed? Okay, so there's a bit more to this. There's a bunch which just have those values. Maybe I should change it to so functions used instead of this lambda. So change this to count, and we'll do wire group into here. This will be return. Maybe it shouldn't be a lambda. I mean, maybe it should be a lambda like this. Wire count equals this. Do I need to use that anywhere else? Is there anything that I can see in wires which 1, 2, 3, 4, 5, 5, 4, 4, 4, 5. Let's print wires dot keys. So 2, 4, 6, 8, 10, 12, 14, 15. Okay, so it's looking at it again, it's going to be more than 3 because we're actually cutting up both ends. So HFX, PCL, and then doing that. Maybe, I don't know, 6 times or something? Does that work at all? Or am I just kind of doing random stuff? BVB, HFX, XHK, so MVD's none there. Okay, so I'm just kind of cutting the longest one, which is not what we want to do. We want to cut the longest one and then one that's connecting to. So with this one, we're looking at the length of all the wires within it. So if we cut a wire, it should no longer be in here. So we should, how do we want to do this? So we've got all wires, we remove a wire from it. So if we remove a wire from this, and then with wires this, we do minus wire group. The length of this is going to return 1 for the group which has a connection to that wire. Okay, let's see if that does anything. What do we have now? That is wrong. Okay, that's very wrong. Is there something else I'm missing, or is that just the wrong approach? Was that kind of? Okay, let's do this for W in wire group. Print wire count W, and we'll do W wire count like that. And let's just print this so we can actually differentiate stuff. Function object is not subscript. What's wrong with that? Do I need to change it to wire or something for wire in wire group? Oh, right, meant to be like this. So first run through, everything's blank, which is expected. Maybe in here we should print this, just so we can see what got removed. So first run through, there's absolutely nothing. Now RHN, should that have been removed? Yes, that should have been removed. RHN goes to, wait, that's not right, is it? HFX PZL. Okay, these are meant to be like on opposing. Maybe that's right. RHN. Oh, let's see what the next one is. XHK. RHN XHK. BVB. HFX. We'll just got added then. NTK. JQT. Wait a minute. I feel like this isn't working properly. If you disconnect the wire between those and create, you'll divide the components into two separate disconnected groups. So I feel like for this, like, we could literally just manually type it in. It's, if you're disconnecting three groups of wires, you're gonna have, wait, so if you disconnect the wire HFX, did I go wrong in this somehow? So I think the reason why this works is because I manually did this. I knew there was going to be 6, so I just typed in 6. So it seems like this is working, but it's this I need to change, because when we do the actual input, it's not going to be 6. So we need to figure out what math this should be. Is there anything about these numbers? Let's do a print. So let's remove this. Print sum of map. Then this is function, so wire group. Then, no, this is wire count. Wire group. Is there anything about these numbers? 0, 4, 7, 9, 12. Actually, we should probably include this here. Maybe there's something about these numbers. Let's do this. 7. So we're just removing the wire which has the most connections. Well, I might as well just put this output for now. So it would be return length of wire group times the length of this, 54. Not for the sake of trying, let's put this input in. It's not going to work, but sometimes you just got to test it. 8, 8. Yeah, as you can see, it's only in 6, which, you know, that's what I did. 8850, too low, which is expected. That's all good. But what maths should I be doing? What maths is needed that gets to the number 6? Or that makes it so there is 6 in this group? Let's remove this count and stuff. Actually, what was that? Wait, why does that, removing that? Wait, is this getting different numbers each time? Let's compare it to this. XHK, RHN, NDQ. So those are all the correct ones. Oh, what about this? This is RZS, QNR FRS. So the one with the correct output has 3. Oh, actually. So it's different groups each time, it seems. So say for this one, RZS, CMG, NVD, FRS, QNR, LHK. None of these are all in the group 9. Then if you do this, still all in the group 9. And these are all still in the group 9. But then, when we get the actual output, the number is 3. So we don't actually know which. So doing it this way, it could be building up either group, depending on, well, because we're using a set, it's unordered, so it could be getting either of these groups. So running it 6 times is correct for building this group, but to build this group it needs to do more, and if it does more, it would get the extra ones. So let's change this to a 9. So, okay, so this is now the bottom group, but how is CMG and NVD? Okay, maybe this isn't the best example to do. Oh, actually, let's take a look at this. QNR, PZL, LHK, FRS, RZS, LSR, CMG, RSH, NVD. It has none of the group's 6 component one in here, and it also output 3. So that must be what we need to look for. So while this does not equal 3, that looks to be correct. So 2, 4, 6, 9. Oh, max is interesting. So it's possible that we get an error. Where's maxing around for this? Remove. Huh. So this means there's a possibility that we get the wrong one or something. Is it possible to do an ordered set? Actually, we don't want it to be ordered because it could be in the wrong order. Yeah, that's kind of the problem with this lambda on the group key. Why it counts a group into this. There are multiple which have the same value initially. It's kind of a luck of the draw which one it gets. We seem to be able to get the correct answer. Just need to run it, so let's get rid of these prints. Just need to run it so we don't get to this. So if we get it, we just run it again, and then hopefully that works. So let's do the real input, and will it work? 547,410. There we go, we've got part 1 done, so let's go on to part 2. You climb over weather machines, under giant springs, and narrowly avoid a pile of pipes as you find and disconnect the 3 wires. A moment after you disconnect the last wire, the big red reset button module makes a small ding noise. System overload resolved. Power required is now 50 stars. Out of the corner of your eye, you notice goggles and a loose-fitting hard hat peeking at you from behind an ultra crucible. You think you see a faint glow, but before you can investigate, you hear another small ding. Power required is now 49 stars. Please supply the necessary stars and push the button to restart the system. You have enough stars to push the big red button. Is this... you supply all 50 stars and restart global snow production. As you reach the edge of Snow Island, you can already tell from way up here that everyone will have a white Christmas this year after all. So congratulations, you've finished every puzzle in Advent of Code 2023. I hope you had as much fun solving them as I had making them for you. Love to hear about your adventure. You can get in touch with me via these links. Okay, so this one only has 2 parts. Oh, 1 part. Okay, cool. So let's go back to here. And we can see the map now where we went all the way through the different locations and back down. Cool. So that is Advent of Code 2023 completed. If you like this video, make sure to like and subscribe so you don't miss out on the future videos that I do.